For this lab, we will be using the freezing point depression to find the molecular weight. Be sure to read the pre-lab materials before you go on with this lab so that you can understand what was going on. We will be making a cooling curve, which is similar to a heating curve, but allowing the temperature to drop as our materials move from the liquid to the solid state. As you have learned in class, the freezing point or melting point of a material will lower as a solute is added to this material. The amount by which it is lowered is represented by this equation number 1. Delta T, or the change in temperature, is equal to Kf times m. Kf is a constant that is specific to each solvent. For our solvent, lauric acid, that constant is 3.9 kilograms per mole times degrees Celsius. The m is the molality, and that is the molality of the solution in moles of the solute, in this case benzoic acid, per kilogram of the solvent, which is lauric acid. We will need to rearrange our equation to solve for m, the molality, first, but remember that the molality is not the same thing as the number of moles. So once we find the molality, we'll have to use the weight of the lauric acid to solve for moles. From there, we will have the moles and the mass of the benzoic acid and be able to find the molecular weight. Our setup is going to look something like this. This is a generic graph of the cooling curve for a pure solvent. Pure substances will melt or freeze at a constant temperature, staying at that same temperature until the phase is completely changed. There are two ways to find what this temperature is. Because the cooling curve very rarely has a sharp divide between the cooling section and the freezing section, you will either need to find the average temperature in the range where it is flat, or find the intersection of the slopes of the two lines. You can see in orange how I've extended the lines of the cooling region and the flat phase change region. The intersection there will give us the temperature of the melting point of the pure solvent. For a solution, the flat region isn't quite so flat. The temperature tends to decrease a little at a time. This is because the melting point is more of a range than an actual point. So we definitely have to use the intersection of the two lines, the sloped region for the cooling of the temperature and the much less sloped region for the phase change. We will extend these two lines back to where they intersect with one another and find the temperature at that point. For this lab, you will need a hot plate, 2 beakers of water, one to be a hot water bath and one to be a cold water bath, a ring clamp on a ring stand, a temperature probe that is connected either by a wire or through wireless connection to our graphical analysis program or Logger Pro, and 2 test tubes. These have already been weighed out for you, so you don't need to do the weighing or the mixing. First, we will melt the lauric acid with the blue label and find the melting point of the pure solvent. Then we will melt the lauric acid with the benzoic acid combined and find the freezing point of the mixture.